Dear student, today I will explain about the integral calculus. See, integral calculus. Okay, can you view my screen? Anyone say can yes?
Yes, sir.
Okay, thank you so much. And dear student, in electrodynamics, there are several different kinds of integrals, and among which most important are number one, line, or also referred to as path. Second is surface integral, surface integral, and third one is, dear student, volume integral. Okay, surface integral is also referred to as, I will use a different color, it's always also referred to as flux. Okay, thus there are three here. We will learn about the three integral: line integral, second surface integral, or also referred to as flux integral, and third one is volume integral. Okay, now I will start first line integral. Can I proceed, dear student? Anyone say can yes?
Yes, sir.
Yes,
Okay.
sir.
Then I will write, dear student, line integral. Okay, line. And therefore, a line integral is an expression of the form. What is the form of line integral? I will use again different color. A line integral is in form of, I will write equation, that is integration of v dot dl from a to b. Say, I will write here equation number one. And now, what is the a? I will shift this backward direction. What is the v? This one, v is vector function. Where v is a vector function. And dl, dl is dl is the dl is the infinitesimal displacement. Okay, see, v is what? V is vector function. See, I will use laser pointer. V is vector function and dl is displacement vector. Okay, and the integral is to be carried out along a prescribed path from point A to B. What is the initial point? Initial or starting point is A and final point is B. Okay, therefore here I will write there I will use and the integral is to be carried out along a prescribed. Okay, and what is the initial point?
Sir, to be carried क्या? At.
Carried out along a prescribed path from point, I will repeat, don't worry, from point A, this is your A, 2, yes, to what? Anyone?
B.
B.
Yes, to point B, that is point B. Means initial position is point A and final position is point B. And therefore, suppose I will draw this diagram. I will draw diagram for this. What I will draw diagram here. Different color. See. Suppose your particle is in three-dimensional case. Therefore, I will draw x-axis, y-axis, and z-axis. Okay. And suppose, dear student, I will use a different color. Suppose A is your position, initial position, and final position is suppose B. Okay. And here particle is traveling from point A to B. Understood? And for this case, we can write integration equation like this. See, for this case, initial point is A and is traveling from A to B. Then for this case, dear student, we can write B dot dl. See, and what is the here dl? See, here this is your path. And for this case, we can write equation like this. For this diagram, we can write equation like this. Understood? Hello, friend. Up to this level.
Yes, sir.
Okay. Now, if the path follows closed loop, means suppose initial point is here A and final point is B, therefore we can write equation like this. But if I will divide this screen into two parts. But dear students, suppose again see, as per this equation, initial point is A and final point is B. Suppose again particle is traveling from point B to A, means here now you will get a closed loop. Understood? Hello student. Yes or no? Hello student. Suppose again particle is traveling from B to again A. Therefore, this is which type of loop? Closed loop. And for this case, dear student, we can write means in this case, initial point B equal to A. Understood? And for B equal to A means such type of loop, we can write. I will put a small circle on this integral sign. Okay, that is B dot dA. Understood, dear student of this level? Hello,
Yes,
student.
sir. Yes, sir.
Hello, hello, student. Hello, now it is clear.
Yes,
Haan,
sir.
sir.
Okay, means for closed loop. See, for closed loop, equation 1 can be written as, for closed loop, equation 1 can be written as equation 2. Understood? Means put a small circle on this integration. Okay? Yes. Understood up to this level? And this is really a dear student about line integral. Hello, student.
सर एक और बार समझाओगे?
Suppose if your particle is traveling from initial point A to up to only B, then you can write equation number 1. But again, initial point is A, traveling up to B. Again, a point is traveling from B to A, and for this case, that is this is the loop. And for this case, you can write equation number 2. For any closed loop, dear student, put a small circle on this integral sign. Okay, that is equation number 2. And this is about the line integral. Understood up to this level?
Yes, sir.
Yes, sir.
Thank you. Thank you. और किसी को hello student, hello student, what is the formula to find out work from the knowledge of force and distance or distance?
Force into displacement is work.
Perfect. Force into distance. Okay, force into distance. Okay, and then therefore I will write example of line integral. Okay, example of line integral is I will use different color. Okay, the most familiar example. The most example of their student. I will write here. Understood your student up to this level? Hello, sir. Anyone second? Yes.
Yes, sir.
Okay, so in exam I'll ask what is the example of line integral. You should write work. Okay, work done by a force. Okay, that is force into distance. Yes, I think there is no query up to this level uh, regarding to line integral. Yes or no? Hello, student.
Yes, sir.
Can I proceed for next point? Hello, student. Okay, dear student, next I will start surface integral, and in case of surface integral, I will write first equation. I will use a different color. Surface integral is an expression of the form, dear student. Here I will write equation for surface integration, that is integration of v dot dA. Okay, for surface S, equation number suppose say 1. Okay, and dear student, again where v is again some vector function and integral is over a specified surface S. And what is the dA? dA is an infinitesimal patch of area and with direction perpendicular to the surface. Okay, I will first I will draw diagram for this case. I will take x-axis, y-axis, and y. Okay. Now I will take surface element. I will use again different color. Okay. Suppose this is the surface element. This is the surface. Okay. With area, dear student, suppose this is the surface element and dA is, I will use again, dA is, I will use red color. Yes, sir. What is the V? Hello, sir. V is vector function. I will write here. There V is a vector. V is vector function and dA is an infinite. Yes, D is what? Infinitesimal patch of area. Take a small part, okay, with area dA and with direction perpendicular to the surface. Okay. See, this is entire surface and take a small part with area dA and this is the perpendicular. This is the patch. Okay, take a small surface element with again take a small patch of area and a direction which is perpendicular to the surface. See, this red color arrow is which is perpendicular, very perpendicular to this surface. Understood up to this level, dear student? And for this case, we can write surface integral is what? B dot dA integration over S. Understood up to this level? Hello, student. Hello, anyone second? Yes.
Yes, sir.
Okay. Again, if the surface is closed, yes, then same equation 1 can be written as, I will take one case here. If the surface is if the surface is closed, important one, closed, then we can write, I shall again put a circle on the integral sign. Therefore, equation 1 can be written as equation 1 becomes integration of V dot dA. Put a small circle on the integral sign. Understood up to this level? Hello, sure. Anyone second? Yes. And in this case, here, see, what is the direction of this arrow? Inward है कि arrow है? Inward है कि outward arrow है? Hello, student.
Outward.
Hello. Yes, super. Outward है. Therefore, also in this case, the direction is outward, and therefore we can say that here this tradition dictates the outward, and always we will consider as a positive sign. But for open surface, generally S is arbitrary. And here we describe the flow of fluid, that is mass per unit area per unit time. Therefore, intuition of VD also represent the total mass per unit time passing through the surface. Hence, alternative word for surface integration is the flux. Okay, तो देखो ये क्या बाहर जा रहे हैं. Okay, these are the lines. I will use laser pointer. The direction is outward. Therefore, here you will get the number of outward lines, and therefore surface integration is also referred to as flux. क्या बोलते हैं इसको? Flux. Therefore, I will make it flux. And this is our today's session. Yes, any doubt of this level? Understood? Next session I will take volume integration. Okay. Yes, dear student, any doubt of this level?
No, sir.